Hello students, now today we are going to discuss some numericals on even and how to find even and odd component of the following signals. And already I told you in previous class, so that is your as far as classification of discrete signal is concerned. So energy and power, how to calculate energy and power signal of a discrete time signal x of n is given, and how to find out a periodic and aperiodic signals. If x of n is given, you have to identify whether the signal is periodic or not. Already I told you how to evaluate or how to determine the periodic and aperiodic of the continuous time signal as well as discrete time signals. As far as symmetric and anti-symmetric signal is concerned, or we can say that symmetric, or we can say that even, and anti-symmetric we can say odd. So as already I told you, in a symmetric or even or anti-symmetric or odd, how to determine even and odd component of a continuous signal as well as discrete signals. So in continuous time signals or discrete time signals, so how to find out the even and odd component of the given signals. So now these examples are numericals based on find the even and odd component of the following signals here. So that means here, suppose this is your n, this is a continuous signal, here we have to sample it. So this is your n and this is your x of n. X axis is your n values of 0, 1, 2, 3, 4, etc. and this is y axis your x of n. And the signal is present at in between 2, 3, 4. At n equal to 2, here the amplitude is your 4. Here the amplitude is 4 here. So that means at n equal to 2, x of n equal to 2, x of 2 equal to 4. At n equal to 3, x of 3 equal to 4, n equal to 4, x of 4 is 4. So that means, so if you sample it as far as this is your continuous, if it is a discrete, we have to sample it, that is your in place of 2, this is 1 and this is 2, in 2 that is also 4, this is your 2, so this is your 4. Similarly in 3 and in 4 is also the value is amplitude is 4, this is your 4, okay, this is 4 and this is also 4. Let this is your n and this is your what, that is your x of n, this is your n and this is your x of n. That means we have to calculate or we have to find out the even and odd component of the signal. How to calculate the even and odd component of the signals? So already I told you, in even component of the signal x e of n equal to x of n plus x of minus n by 2, and odd component of the signal, that is your x of x o of n equal to x of n minus x of n minus n by 2. So I just make a table so that it will be easy for you to find out the even and odd component of the signals. So in a table, first of all, this is your n, let this is your minus 5 and this is your minus 4 and minus 3, minus 2, that is your minus 1, 0, 1, 2, 3 and 4. And then x of n, when I have sampled it, I will found at n equal to 0, the value is 0. At n equal to 0, the value is 0. There is no signal at present at the n equal to 0. At n equal to 1 also, there will be no sampled signals. So n equal to 0, the value is 0. N equal to 1 also 0. N equal to 2, n equal to 2, x of 2 is how much? That is 4. N equal to 2, x of 2, that is your 4 also here. And n equal to 3 also 4, n equal to 4 also 4, n equal to 5, that x of 5, that is your 0, like this. So except n equal to 2, 3, 4, no here the signal is present. That's why n equal to 2, 3, 4, the x of n, x of 2 is 4, x of 3 is 4, x of 4 is 4. N equal to 2, x of 2 is 4, n equal to 3, x of 3 equal to 4, n equal to 4, x of 4 is 4. Otherwise, the value will be 0 elsewhere. This is your x of n, and remaining values of n, the value x of the function will be 0, like this. This is your x of n. Then we will calculate x of minus n, x of minus n. This is also folding. Whatever n equal to 0 as it is, whatever the value of n equal to 1, whatever 1, 2, 3, 4, 5, it is same as it is in n equal to minus 1, minus 2, minus 3, minus 4, like this. N equal to 0, whatever n equal to 0, the value is present here same. Whatever n equal to 0 1 here like this, it will be shifted to the n equal to minus 1, minus 2, minus 3, minus 4. N equal to 1, whatever n equal to 1, that will be n equal to minus 1, it will be 0. Whatever n equal to 2, n equal to 2 is 4, becomes n equal to minus 2. Again 4, this is also 4, this is also 4, this is 4, all are 0, except like this. We can say folding. Whatever n equal to minus 1, minus 2, minus 3, minus 4, minus 5, it is same as in n equal to 0, 1, 2, 3, 4, 5 like this. That means whatever n equal to 1, 2, 3, 4, 5, it becomes n equal to minus 1, minus 2, minus 3, minus 4. Whatever n equal to minus 1, minus 2, minus 3, minus 4, 5, it is simply shifted to the n equal. It is just swapping. So that means n equal to 1, 2, 3, 4, 5, it comes to n equal to minus 1, minus 1, minus 2, minus 3, minus 4, minus 5. Whatever this is your minus 1, 0, 0, 0, 0 like this, 0, 0, 0 like this. Simply whatever positive value of n, 1, 2, 3, 4, 5 comes to the negative value of n. Whatever the negative value of n comes to the positive value of n. This is nothing but x of minus n. Then what we'll do? We are going to calculate the even component of the signal. The even component of the signal x e of n, in previous class already I also derived it. X e of n is nothing but what? That is your x of n plus x of minus n by 2. X of n plus x of minus n by 2. Simply whatever like this, simply you just added this x of n, this is your x of n, and this is your x of minus n. So this plus this by 2, 0 plus 0 by 2 is also 0. 0 plus 4, 0 plus 4 is 4, 4 by 2, it is nothing but 2. Similarly 0 plus 4, 4, 4 by 2, 2. 0 plus 4, 4, 4 by 2, 2, 2. 0 plus 0, 0, 0 by 0. Here also 0. Here also 0 plus 0, 0 by 2 is also 0. 4 plus 0, that is 4, 4 by 2, that is 2. Similarly, that is your 4 plus 0 by 2, that is your 2. Similarly 4 plus 0, 4 by 2, 2. Here also 2, here also 0 like this. So this is nothing but x e of n. Same thing, this is nothing but, if you observe, whatever this side, left hand side of 0, it is exactly same as the right side of 0. That's why we will say this is an even part of the signal, or we can say that symmetric. That is a symmetric, or we can say to find out the even component of the signal, and this is nothing but your even component of the discrete signal, this one. So this is nothing but what? Even component of the signal. Next we are going to calculate odd component of the signal. So odd component of the signal is what? X of n is nothing but what? That is your x of n minus x of minus n by 2. This is nothing but your odd component of the signal. So in odd component of the signal, this is your x of n and this is your x of minus n. This minus this by 2. 0 minus 0, 0 by 2, that is 0 also. So 0 minus 4, that is your minus 4 by 2 is nothing but minus 2. 0 minus 4, this minus this. 0 minus 4, minus 4 by 2, this is nothing but minus 2. 0 minus 4 by 2, this is nothing but 0 minus 2. Minus 2. So this is also 0. Similarly, so here 0 minus 4 by 2, this is nothing but minus 2. Similarly here 2, 3, 4, again this is your 0, again this is your 0, here 0, this is also 0, same thing 4 minus 0, 4 by 2, that is your plus 2 here, 4 minus 0, 4 by 2 plus 2, 4 minus 0, 4, that is 2, that is your 2 here, like this. So then we will draw, that is your even and odd component of the signal. So here this is your 0, then this is your 1, this is your 2, let 3, and this is your 4. Similarly minus 1, and this is your minus 2, this is your minus 3, and also this is your minus 4. When we are going to calculate the even and odd component of the signal like this, so this is your n, this is your n. Now we are going to calculate x of n. Then this is your even component of the signal, n equal to 0, n equal to 0, that is 0. Then at n equal to 2, 3, 4, that is what? N equal to 2, 3, 4, that is your 2, 2, 2, like this. So n equal to 2, 3, 4, that is 2. This is your 2, 3 also 2, and 4 also 2. This is your n, and this is nothing but is your what? X of n. Similarly, n equal to minus 2, minus 3, minus 4 also, minus 2, minus 3, minus 4 also, 2, 2, 2. Here also 2. This is also 2, and this is also 2. And the amplitude is what? That is your 2. So if you observe, this is nothing but an even component of the signal, x e of n. This is your plot. This is nothing but what? Even component of the signal or symmetric component. Or even means what? Symmetric of discrete signal x of n, and this is your whatever, that is your right hand side of plus right hand side, and exactly same as the left hand side. So that's why you can say that this is the even component of the signal or symmetric component of the signal, discrete signal x of n, this one. So second one is your how to find out the odd component of the signal. If you will find out the odd component of the signal, similarly we have to draw the odd component of the signal. Here that is your 0, 1, 2, 3, let 4, then minus 1, minus 2, then minus 3, also this is your let minus 4. For odd component of the signal, how to draw the odd component of the signal? This is your 0, and this is nothing but x of n. X axis is your n, and y axis is your x of n. We have to draw the odd component of the signal. The odd component of the signal x of n, what? N equal to 0, n equal to 0, 0, n equal to 1 also 0, n equal to 2, that is 2, 2, 2, n equal to 2, 3, 4, n equal to 2, 3, 4, here n equal to 2, n equal to 3, n equal to 4, n equal to 2, that is your x of 2, 3, 4, here. For odd component of the signal, this is your odd component of the signal. For odd component of the signal, this is your 2, this is 2, this is 2. 2 for what? N equal to 2, n equal to 3, n equal to 4. For n equal to 2, let this is your 2, 3 also 2, 4 is also 2. So the amplitude is your 2. Similarly, for n equal to minus 1 also 0, n equal to minus 0 also 0, n equal to minus 1 also 0. Here or minus 2, here minus 2, this one for what? N equal to minus 2, n equal to minus 3, n equal to minus 4. N equal to minus 2, that is your what? Minus 2. If this is 2 and this becomes what? That is your minus 2. So n equal to minus 2, this is also minus 2 here, this is also minus 2, and this is also minus 2. Okay, this is nothing but your odd component of the signal. So this is nothing but even component of the signal, and this is nothing but your odd component of the signal. For even component of the signal, it is symmetrical about y axis. Whatever the value of the right hand side of 0, exactly same as the left side of the 0. Here also, like this one, this is nothing but your odd component of the signal. Odd component of the signal, which signal? This one. If a discrete signal x of n is given, you have to calculate or you have to find out the even part of the signal and odd component of the signal. In odd component of the signal, the condition is what? To find the odd component of the signal, the formula is your what? X0 of n equal to x of n minus x of minus n by 2. To find the even component of the signal, xe of n equal to x of n plus x of minus n by 2. So first of all, if a continuous signal is given, this is nothing but a continuous signal. This is a continuous signal. This is your t here, and this is your x of t. If continuous signal is given, first you have to sample it, and this is nothing but a discrete signal, and then you will find out the even and odd component of the signal, or symmetric or anti-symmetric of the signal. So thank you. So next class again we will do more and more number of numericals to find out the classification, as far as classification of discrete signal is concerned. Already we have covered of that is your periodic, aperiodic signal, energy and power signal, symmetric and anti-symmetric signals, like this. Thank you. We will meet again.